to this computer. All right, we are recording on this computer now, I think, and we're going to share my screen. And we're going to do comparative social evolution. This is my second time giving this lecture to you guys, so presumably I'll do a much better job. Let's see. Comparative social evolution, we're going to have the first section of the intro course today, which should be for Wednesday, like the 10th, 9th, whatever, the first day of class. So comparative social evolution is the course that you're in. We'll review a couple of things from the syllabus that I think are most salient, and then we will pivot into describing social interactions in terms of their ecological outcomes. All right, so course mechanics, there will be 20 to 50 minute pre-recorded lectures provided 3 times per week. I will endeavor not to be anywhere near 50 minutes, but there's a chance that I'll just start yapping along. In fact, I should check myself right now. Okay, it's like 8:36 a.m. Okay. I'll have office hours every Friday from 2 to 4 o'clock. That will be done virtually via Zoom. I'll send out an invitation to everybody. I'm your instructor, Jonathan Pruitt. I'm a professor in psychology, neuroscience, and behavior at McMaster University. Grading. You've got those 2 midterms and a final. Each of those midterms is worth 30% of your grade. The final is worth 40%. Each question on the exam will be multiple choice. It will have 5 options, and I will try to create exam questions that can differentiate those of you who are simply skimming through my lectures versus those that have really done the work and committed these things to memory and then also to fluency. So please, please, please watch my lectures a couple of times. Please, please, please. Turn these lectures into note cards and then study with each other to make sure that you are fluent and can would be capable of teaching the material if you were called upon to do so. And in the exam, you're going to have to bring all of that knowledge to bear on novel topics and novel questions in a 30 to 50 question multiple choice format, and I'll give you approximately an hour to execute that. You have to be fluent. I've told you once before, but I'll tell you again. Just please try to make detailed notes, review those notes. I like note cards best, and most of you will find by the time you're done making the note cards that you basically know what's on them. All right, goals for this course. I want you to be able to describe various philosophical approaches to the study of social evolution. What are the tools that we use to describe social interactions, their structure, societies and how they are structured, and then the sorts of difficulties that societies endure as a consequence of their various kinds of structures. I want you to be able to realize that the same sorts of problems and structures for sociality have emerged over and over again across various kinds of taxa, from microbes to humans. And we'll focus on animals in this class, but I mean, most of the content that we're describing could be applied to microbial societies, plant societies, et cetera, et cetera. And then I hope that you'll be able to understand how the science of social evolution is advanced. Like, what are the tools that we use? What are the ways that we acquire information? How do we address our hypotheses and evaluate whether or not they're true? The schedule's not fixed, everybody. So heads up. We are going to have the intro lectures this week, but they're probably going to bleed into next week. The kin selection and multi-level selection might get completed next week or might take a little bit of extra time. A couple of the topics are significantly shorter. So dominance hierarchies and animal leadership, those units that are pre-created right now, are intentionally somewhat more concise because I think I will probably end up falling behind somewhat in the first few lectures. And I do want to have regularly scheduled class times where you can interact with me in real time and I can answer your questions, because right now I'm just assuming that you understand everything that I say perfectly and that you're all, you have no burning inquiries, you want no supplementary information, that you're just totally satiated, which can't possibly be true. And so I do want to have those virtual office hours and virtual class times that you can ask for clarification and ask for additional information where you want it. I'm an expert in this topic. I am your resource, and I'm here because I'm supposed to be an educator and an effective one and devoted one for you guys. And that is an obligation that I take quite seriously because that's my job, my real job. Anyway, so there's a course book for this. The book's, although I've said that the book's not required, and it's not genuinely required, it is encouraged that you buy this book. The taxonomic lectures in the second half of the course, weeks 7 through 13, are going to come out of this book almost verbatim. We're going to take skeletonized elements of this, and then I'll supplement those skeletonized versions of these chapters with what I think are the coolest elements about the biology of the various taxa. So it'll be colored a little bit by my preferences, or enhanced by my preferences, not just biased. But weeks 1 through 7 are going to be theoretically based in terms of modeling, and they are not going to be relying from this book. It's a good book. It's a nice reference tool. It's nice to have around. You might enjoy reading it. So I hope that you will buy this book. But again, if you're strapped for cash and you're looking for ways to save a few dozen dollars, then yeah, you don't have to have this. You can probably share it with somebody else. I think I might even have a digital copy of it that I'm probably not allowed to share. Maybe I can share it. We'll see. Anyway, I probably can't. I purchased it from Amazon, and it was pretty restrictive how I could read it myself. But if I can share it with you, I would share it with you. I will share it with you. All right. So topics for this course, for this first lecture, rather. How are social interactions categorized in terms of their ecological terms? Secondarily, how does evolution work? So I'm going to operate on the assumption that you probably have heard about how evolution works since, I don't know, since you were like in elementary school, middle school, maybe high school. But I'm going to assume that you have forgotten all of that. And I will give you a little crash course in social evolution and hopefully add to your pre-existing knowledge, even if it's quite firm. Then we will talk about the evolvability of sociality. How do you get sociality to evolve from a pre-existing population of aggressive individuals? So social behavior usually comes from less social ancestors. So if you're the first altruistic individual inside of your population surrounded by a bunch of selfish ancestral traits, how do you get off the ground? When you try to cooperate with another individual and it means to kill you, how does that work? Can it work? Yeah. Well, I mean, obviously, to some degree, it has to be working because you and I are social. And lots of other organisms like these gelada monkeys on the right-hand side of this screen are social. So it does work, but how does that happen? And then lastly, what are the special features and challenges for the evolution of social phenotypes? So what special barriers exist for the evolution of altruism, cooperation, things of that nature? So how are social interactions categorized in terms of their ecological outcomes? It's all about costs and benefits, right? And these terms will be categorized as though there was one donor, which is the individual that exhibits the behavior, and then the recipient are the impacted individuals that are the recipient of that behavior. So a donor might be engaging in an aggressive interaction. I chase after you, or I try to steal your mate, or I try to or steal food from you. Or maybe I come over and I preen you and try to pull parasites out of your hair, or maybe I come over and I groom you, or maybe I share my food with you. So all of those things that I initiate, that I'm the donor of those interactions. The recipient is the one that receives the outcome of that interaction. So there's a little Punnett square type thing here. If the donor is doing something that helps it, but it also helps you, then that is viewed as cooperation. Cooperation does not mean that I'm hurting myself to help you. Cooperation means I'm doing something for you that's good for me and good for you. Rising tide lifts all ships. Cooperation, cooperative behavior. A lot of texts sort of conflate altruism with cooperation. I don't do that. Cooperation is mutually beneficial. altruism. I'm going to do something that is going to negatively impact my performance, usually in terms of my reproductive output, but there oftentimes are proxies like the amount of calories that I consume, or the amount of time that I have available, or risked bodily injury to me or death that is going to help you. So I incur a cost, you incur a benefit. As the receiver, I'm the donor in this instance. That's altruistic behavior. You know, like, I'm hurting myself to help you. It's altruism. Spite. Spite is actually pretty uncommon in ecological systems, we think, but that's where I'm going to hurt myself to hurt you. And that's, for a variety of reasons, difficult to evolve, but humans exhibit spite all the time. And so we'll talk about a human example in just a second. And then there's selfishness, which is very obvious. I'm going to do something that's going to help me, and it's going to hurt you. Easy peasy. I'm being selfish. Help me, hurt you, selfish. Make sense? All right. All right, so a classic example of altruism might be something like parental care, where a mother, typically it's a mother, but sometimes it's biparental, a mother and a father, a parent gives of themselves for their offspring, self-sacrificial behavior. So this is depicted here is this sort of like purplish blue caecilian, which are subterranean amphibians that are quite diverse in the tropics. We know very little about them, but what we do know is a lot of them have parental care. So these little wormy things are nestled in the interior of this coil of the caecilian are her offspring. And the offspring of most caecilian mothers live on the interior of their mother's reproductive tract. And the reproductive tract of the mother basically becomes like leathery as her offspring develop, and then begins to slough off, producing a kind of like weird proteinaceous milk. And her offspring scrape that off of her interior, and then one day she produces her offspring, forces them out. Anyway, so during that process, that mother is losing tons of nutrients that are then being imbibed by her offspring. And so she is losing caloric value, which might, if she wasn't giving it to her offspring, she might have been using it to grow her body, to fight off infections, to produce the next set of offspring. So she is giving of her own resources for her offspring's benefit. So she is the altruist who is incurring a cost as the donor for the recipient, her offspring, to obtain a benefit. Makes sense? Self-sacrificial mom, Mother of the Year award. All right, spite. Well, spite is a situation where somebody's going to hurt themselves to hurt you, usually more. So difficult to come up with examples, real examples in the animal world, but humans are filled with spite. We have such strong spiteful tendencies from a very young age. So the most common and sad example of spite in human studies is probably the dictator game. The dictator game is basically any kind of game where one actor has total control over the resource distribution between itself and some other individual, the non-dictator, the recipient. Anyway, so these games are oftentimes played out with morality in children to explore the evolution of our own altruistic tendencies. And quite often we find that children are very spiteful. And humans have instincts to be incredibly spiteful. So a classic game might be something like this. The dictator child has one of two options to distribute jelly beans. In the first case, the dictator child can take 2 jelly beans. And then the second child, which I'm going to humorously call the victim child will get 1 jelly bean. So 2 for the dictator child, 1 jelly bean for the victim child. Or alternatively, the second option is that the dictator can have 4 jelly beans, twice as much as it could have from the other option. But then the victim child would get 4 jelly beans. Which do you think the dictator child tends to choose? Well, with option 1, there are fewer jelly beans overall. There's between the victim child and the dictator child, you're only going to get 3 jelly beans. And the dictator's only going to get 2 themselves. They could get twice as many if they allow themselves and their victim child to have 4 jelly beans. What do you think most children choose? The 2 versus 1. So despite the fact that you could get more jelly beans by having equitable distribution of resources, This is actually very painful psychologically for those children. They want to have more than someone else. So it's less important in most children's minds with these distribution of resource games that they have more than somebody else than the absolute value of the resources themselves. That is a fine example of spite. You're hurting yourself by choosing fewer resources, fewer jelly beans in this case, but the fact that you're advantaging yourself over another individual satisfies the cost in the minds of most actors under these staged scenarios. So yes, it's highly contrived. Yes, it's just jelly beans, but it tells you something very dark in terms of inferences about fairness and the importance of relative performance in the minds of humans. So this is some evidence of spite being quite endemic to humans and powerful and determined relatively early on in development. Dictator games, scary stuff. Cooperation, much less frightening. Cooperation abounds all over the animal and non-animal world. Cooperation can be intra-specific, which is cooperation among multiple individuals of the same species, or interspecific. So intra, like down here in the right-hand corner, would be something like these African painted dogs that cooperate together in shared hunting events. So by working in concert, these individuals are able to fatigue their prey, to ambush their prey, to execute cooperative hunting strategies that are much more efficient. And they allow all members of these packs to obtain more resources, more prey, more caloric intake than they would be able to obtain by working on their own. So cooperative hunting lifts rising tide, lifts all ships. All the participants involved obtain a benefit from this. That doesn't mean that the benefits are equitably distributed. There are probably some individuals in this pack that get more resources than others, but at least relative to their solitary hunting counterparts, it is advantageous to be working in these cooperative hunting units. And they're intra-specific because they are composed of multiple individuals of the same species cooperating with each other to their mutual benefit. Interspecific cooperation is oftentimes called ecological mutualisms, but that is where multiple interactors of different species are interacting with each other to their mutual benefit. This is an example might be like clownfish and anemones. They're very common because oftentimes the different interactors, say these fish and these anemones, are capable of very different biological outcomes and obtaining different kinds of resources. And so normally with mutualisms, they're exchanging very unlike currencies for each other, and they're competing with each other less. Like this clownfish and this anemone, they don't have a lot of resources that they're fighting each other for. Like this anemone probably has zooxanthellae, tiny little microbes in the interior of its tentacles that make sunlight really important to it. And it doesn't have to worry about these clownfish competing with it for sunlight. It's mostly irrelevant, the shadow that these clownfish produce on these anemones. Versus if there were two anemones together trying to cooperate, they could try to shade each other because they would be fighting for light or fighting for preferred space on a rock or a coral head or whatever. So the anemones here, the anemone and the clownfish have a benefit in terms of their cooperation that one, they can provide each other with very different kinds of benefits. And two, they're competing with each other less because there's very little ecological overlap in their resource needs. So the anemone provides these clownfish with protection from predators and a space to live and a space for them to produce offspring that's relatively well protected. Clownfish are notoriously terrible swimmers. So if they leave this clownfish, or that they leave this anemone, they'll die very quickly. The clownfish need to live in this anemone. If they don't, it's bad news bears. They're usually dead in a matter of hours on the reef. Reefs are dangerous places. And conversely, the anemones benefited because these clownfish consume tons of zooplankton in the water column and tiny little bits of flotsam floating around like organic macromolecules. And then they basically urinate and defecate all over these anemones. And these anemones obtain nitrogen from that urine, from that feces, and that allows the anemone to grow faster. So both the anemone and the clownfish have a benefit that they obtain. It's usually in different currencies, and they're competing with each other less. So interspecific cooperation happens quite regularly, and clownfish and anemones are just one example of that. Selfishness. I'm gonna hurt me. I'm going to hurt you to help me. All right, there we go. So like, this is a very common kind of social interaction. It's probably the most common kind of social interaction in not terribly highly integrated societies. So the average social interaction that occurs among primarily solitary living organisms is selfish, stealing resources, stealing mates, stealing preferred territory, forcing other individuals out. Here are two combatant hippopotamuses. I think it's Greek, so I think it's hippopotamuses, but people say hippopotami. I think it's Greek, so it should probably be hippopotamuses, but whatever. These two male hippopotami bulls are probably fighting each other for access to a bunch of cows and reproductive rights to those resident females, and possibly foraging rights in that territory as well. So this aggressor male is trying to extirpate this resident male. That is entirely selfish. If this aggressor male successfully forces out the resident male, then that resident male is going to have less reproductive output in the future, reduced access to these females, and possibly reduced safety as it sort of bumbles around and tries to find a new place to live and reproductive rights to a new group of females. The aggressor would then obtain a benefit. That would be a selfish interaction. The aggressor is trying to help itself at the cost of the recipient, i.e. the resident male. And then probably the aggressor male will then go around killing all of the former offspring of the last male and then re-inseminating those females, which would also be costly to those females. So aggressive interactions, selfish interactions are quite common. Costs and benefits are obtained from myriad different kinds of currencies. So it could be in terms of calories consumed. I might gain more calories or have fewer calories as a consequence of my behavior, and it could change your caloric intake or output as a consequence of you being the recipient of these interactions. It could change the number of mates that I acquire or you acquire, the amount of energy that we have to waste or water that we have to consume or spend over the course of the day or the evening or the winter or whatever by our social interactions. It could also be biomechanical, right? So I might be doing something that changes the amount of drag that you experience during migration or as we swim together in the water column. Our behavior might change the amount of predation risk that we experience, our detectability to predators, our probability of being perishing when a predator detects us and attacks us, the amounts of parasites that we acquire or reduce, the migratory routes. So some of the times the ecological currencies that are being exchanged are quite difficult to calculate in terms of fitness impacts, but it might be that because of my behavior demonstrating a migration route to you, that you now know a more efficient migration route to the nesting site or to the foraging site during the winter or the spring, during the fall or the spring. And that could have lifetime consequences for your reproductive output that can be very difficult to obtain because we don't really know what would have happened to you if you'd had a different migratory route. You might learn something about novel resources. So by me demonstrating, say, that we can open trash cans and that we can consume anthropogenic resources from the trash of humans. I mean, trash is filled with calorically rich items that animals would want to consume. So maybe by me demonstrating that, you learn about a totally different kind of resources that could be calorie rich, that could sculpt your performance the rest of your life. And there are many more. So the holy grail thing that you want to be able to calculate for determining the nature of a social interaction is the change in an individual's fitness as a consequence of its experiencing or exhibiting the behavior, being the donor or the recipient. The problem is that that's very, very difficult to do. If I feed you one time in your whole life, if I share a fruit with you and you consume 80 macrocalories, kilocalories, and then I leave the group, how does a scientist determine the net change in your reproductive output or mine as a consequence of that one event? How would you know? Who would you compare it against? We can't replicate history and have another instance where I didn't give you the fruit and then simulate what would happen to us years later when we reproduce or months later when we reproduce. It's very difficult to track fitness as a consequence of singleton interactions social interactions. So oftentimes people use proxies. And although that's imperfect, we don't really know how one fruit or 17 fruits or whatever changes your reproductive output in a very fine way, or my own. We accept that to some degree, me giving that to you gives you calories, and individuals that obtain more calories tend to have greater reproductive output. How much more? It's hard to know. But anyway, so the Holy Grail is to contextualize these ecological outcomes in terms of their reproductive impacts, but that can be quite difficult to do. So sometimes we use survival or energy efficiencies or caloric intake or parasite numbers as proxies because that's what we can measure, and we know, at least to some degree, they are correlated with lifetime reproductive output, although imperfectly. There are some instances where individuals with tons of parasites still end up inseminating lots of females, or she gets tons of food and so she produces big clutches, et cetera, et cetera. So it's imperfect associations, but it's the best we can do under many circumstances. So I guess right now I should probably be quiet. I don't know exactly how long it has been, but I'm going to cut it off now, assuming that you're going to listen to this lecture in addition to the lecture I just gave on the syllabus on Wednesday, and then I will probably do the evolvability of society's middle two units for the Thursday section. So the Wednesday section was the syllabus plus this first quarter, and then the Thursday should be the second two quarters. So I'm going to leave it there for now, and then I will circle back in, I guess, a day, if you're going to be watching this a day later. Anyway, so when you watch these things, is immaterial to me. But please, by Friday, please watch the syllabus lecture on the first three quarters of this unit. Make sense? Okay, cool. Talk to you soon. Take care. Bye. Wait, not bye yet. You're still being recorded. All right, now, goodbye.